अस्सलाम वालेकुम एवरीवन। उम्मीद करता हूँ सारे के सारे खैरियत से होंगे। तो आज की इस वीडियो में वेलकम बैक। टुडे वी आर गोइंग टू टॉक अबाउट द इन टुडे वी आर गोइंग टू टॉक अबाउट environmental system. Okay, so let's start our today's lecture. System are regularly interacting. Sorry, glasses लगा रहा हूँ, थोड़ा सा मसला अच्छा अभी बेस्ट हो। तो are regularly interacting are independent group of items forming a unified whole as a group of interacting bodies under the influence of related functions, related forces. Number B, a group of body functions that together perform one or more vital functions. Number 3, a group of related natural objects or forces. Number 4, a group of devices or artificial objects for an organization forming a network. Characteristics of system. All systems have some structures or organization. They are all to some extent generalizations or idealization of the real world. They all functions in some way. There are therefore functions as well as structured relationship between the units. Function implies the flow and transfer of something. Function requires the presence of some driving force or source of energy. All systems have some degree of integration. Defining systems. Systems are defined by boundaries. They distinguish between the elements of interest and surroundings. Each element has a set of attributes, traits, or properties. Relationship. Define how the properties of two or more elements relate to each other. The surroundings are a motivation. Isolated systems. No interaction with the surroundings across the system boundary, only approximated under laboratory conditions. Closed system. Energy can be transferred across the system boundaries, but matter cannot. These are rare. Open systems, both matter and energy can be transferred across the boundary. Systems can be of any scale: global water scale, continental watersheds, regional aquifer, lake, Bedouin zone of an irrigated plot, Baker in titration experiments, raindrop, bacteria cell, monolayer of water on a particle surface. This is the soil extraction system. Take home message. Systems are abstractions that provide simple descriptions of a complex real world. As much their usefulness depends on how they are defined relative to the how the abstraction will be used. Unfortunately, there are rules. Fortunately, trial and error works pretty well. Units. Solid concentration, most commonly expressed as mass of substance per mass of solid mixture. Common prefixes are here. Liquids concentration, most commonly expressed mass of substance per unit volume of mixture, milligram per liter, microgram per liter, gram per meter cube. Perspectives on the concentration. 1 ppm is a 1 drop in 15 gallons. 1 ppb is 1 drop in a large swimming pool. 1 pbb is 5 people out of the earth's population. For solutions and mixtures, the conversion of liquid concentrations. For solutions and mixtures that are mostly water, 1 kilogram of mixture is equal to 1 liter. 1 milligram that's given gases volume of gaseous pollutants to 10 6 volumes of air. Volume ratio is used because concentration are independent of pressure and temperature changes. Volume of an ideal gas is equal to PV is equal to 1 RT, that we had already been studying since our intermediate. Volume of ideal gas N is equal to PV over RT, that is equal to 0.04 mole. That is converting ppm to milligram per meter cube that we use. Converting ppm to milligram. Here 1000 liter of air in a bar is analyzed and found to obtain 0.078 of carbon monoxide. Is this a problem? Look up a standard for a workplace air is standard pocket guide to chemical hazards. 8 hour time weight exposure limit is equal to 50 ppm. Converting ppm, this is the given. Biological agents, bacteria, viruses, biotoxins, additional agents of concern, model microorganisms. Possible contamination, complete system contamination, raw water source, treatment plant, storage facility, local district contamination. Environmental ethics. Ethics are discussed by philosophers, lawyers, conservations. Environmental ethics are given. These are what is environmental engineering of global perspective. The major environmental problems are air pollution, water waste pollution, food supply problems, and biodiversity depletion. Environmental groundwater, hydrology groundwater sources quantity, aquifer systems parameters, rate and directions of GW flow, Darcy's law, government flow relations, discharge and discharge zones, well mechanics, pumping for water supply, hydraulic control or injection of wastes. Groundwater resources quality, contamination sources, contaminant transport mechanisms, rate and directions of GW migration, feed processes, chemical, biological remediation systems for cleanup. Trends in these are the lectures of today. Inshallah, next we will talk about another topic. Hope for the